questions 1 through 4 on the 2002 grade 12 Euclid math contest. If M 7.7 is the midpoint of the line segment which joins R14 and SA10, what is the value of A? So if you have 2 points, you have A and 10, and that's S, and you have R, which is 1, 4. The midpoint is basically found by adding the terms and dividing by 2. So it would be A plus 1 divided by 2, and 10 plus 4 divided by 2. This is the midpoint. Now they tell you that that midpoint is M 7, 7. So each of these equals 7. So this is 7 and that is 7. So we'll just use the first one because that's the one that has the A. A plus 1 over 2 is 7, and therefore A plus 1 is 14. And solving for A, you get A is equal to 13. So what is the value of A? A is 13. In the diagram, points 3, 2, 11, 2, and 11K form a triangle with area 24 where K is greater than 0. What is the value of K? So here we have a triangle, and they've told you that this is a right angle, and this is K and this is 2. So that means that this side has a length of K minus 2. It's just basically the y coordinates. And then this side right here, this is 11, this is 3, so this is 11 minus 3, which is of course equal to 8. Now the area of a triangle, as we all know, is 1/2 base times height, and they give you the area is 24. So 24 is equal to 1/2 base times height. The base is 8, and the height is K minus 2, like that. So let's see here, 24 is going to be equal to 4K minus 2. 24 divided by 4 is 6, is equal to K minus 2, and therefore K is equal to 8. And moving right along, we've got the next one. Lines are concurrent if they each pass through the same point. The lines y equals 2x plus 3, y equals 8x plus 15, and y equals 5x plus b are concurrent. What is the value of b? So all these lines have a common point. 2x plus 3, y equals 8x plus 15, and the final one which has the value of b. So what first I'm going to do is just concentrate on these two. Since they share a common point, we can find that common point by setting them equal to each other, like that. And this is just a basic algebra problem. So we got 3 minus 15 is equal to 8x minus 2x. So minus 12 is equal to 6x, and therefore x is equal to minus 2. And then now I can concentrate on these two and use x equals minus 2. So first set them equal to each other. And then I can plug in x equals minus 2 as my common x coordinate. So I've got 8 times minus 2 plus 15 is equal to 5 times minus 2 plus b, like that. So we got minus 16 plus 15 is equal to minus 10 plus b, like that. And this is minus 1 minus 10 plus b, and therefore b is equal to 10 minus 1, and therefore b is equal to 9. The quadratic equation x squared minus 3x plus c is equal to 0 has x equals 4 as one of its roots. What is the second root? So we've got x squared minus 3x plus c is equal to 0, and x equals 4 is one of its roots. So let's say the roots were r1 and r2. This can be written, therefore, as x minus r1 times x minus r2, if those were the roots. And we can expand this guy here x squared minus xr2 minus xr1 plus r1 r2 like that. And factor this out to make it look like this. So that would be plus minus r1 minus r2x, and then that one is just r1 r2. And we know that basically these terms have to match, so I'll circle them in a different color. So this has to match this, it's the coefficient in front of x, and the c has to basically match r1 r2 like that. So we can proceed in two ways, but I'll just proceed by setting the 3 or the minus 3 equal to this. I think that should be sufficient. So that means that minus 3 is equal to minus r1 minus r2 like that. And we know that one of those roots is 4. They've given you that in the question. So minus 3, if I let's say r1 equal to 4 like that, we have minus 4 minus r2 like that. And put r2 on one side, you get minus 4 plus 3, and therefore r2 is equal to minus 1 like that. And I think that's all they want. Yeah, the second root. So the second root is negative 1. The rational expression 2x plus 1 over x squared minus 3 may be written as 2 plus a over x squared minus 3, where a is an integer. What is the value of a? So we've got 2x squared plus 1 over x squared minus 3. A is equal to 2 plus a over x squared minus 3. So they've just rearranged it in that form. So what we can do is try to match this all up, get a common denominator, and off we go. So the common denominator is going to be x squared minus 3, so we got 2 over 1 like that, plus a over x squared minus 3 like that. And then multiply, you get 2x squared minus 6 plus a all over the denominator x squared minus 3. And that is equal to 2x squared plus 1 over x squared minus 3. And then the bottoms cancel the denominators, so you're just left with 2x squared plus 1, 2x squared plus a minus 6. We can rearrange it, makes it look a little better. And then now that means the 2x squareds disappear, and we just get left with a is equal to a minus 6 is equal to 1. And solving for a is therefore equal to 7. Part C. The parabola y is equal to x squared minus 4x plus 3 is translated 5 units to the right. In this new position, the equation of the parabola is y equals x squared minus 14x plus d. Determine the value of d. So first, I'm just going to concentrate on that. I'm going to draw a rough sketch and get an idea of what this parabola looks like. So I don't really know, but all I know is the equation. So I'll just start plugging in some basic values. How about when x equals 0? When x equals 0, y is 3. So that's one value, approximately there. Let's say that's 3. And I could probably factor this. So I'm going to do that. Y is equal to, let's see here, x, 3, 1, negative, negative. All right. So that gives me my roots basically. X is negative 1, or sorry, positive 1 right here. And x is also 3. So approximately here. So something like this. This graph looks like something like this, approximately. All right? Not the greatest sketch in the world, but you get the idea. Now, what we do is we take this graph and we translate it 5 units to the right. So we're just shifting it that way. So let's do that. So if this is 0, 3, that point is now going to go to 0, 5. So 1, 2, 3, 4, 5, approximately here. 0, 5, or sorry, 5, 5, 3. 0, 3 becomes 5, 3 when you translate it 5 units to the right. Okay, so I hope you're convinced of that. And now that point is on this new parabola. So I don't really need to draw it in. I don't want to mess up this diagram, make it more confusing, but you hope you get the idea. We're translating all the points 5 units to the right. So we have 1 point for sure. It went from 0, 3 to 5, 3. So now our new parabola, we are given the equation like that. Y is equal to x squared minus 14x plus d. And now we can just sub in this point right here. And we can solve for d. So y is 3, x is 5, like this. And that's d. So we've got 3 is equal to 25 minus 70 plus d. And therefore, we've got 3 is equal to minus 45 plus d. And therefore, d is equal to 48. Three bins are labeled A, B, C, and each bin contains 4 balls numbered 1, 2, 3, 4. The balls in each bin are mixed, and then a student chooses 1 ball at random from each of the bins. If A, B, and C are the numbers on the balls chosen from bins A, B, and C respectively, the student wins a toy helicopter when A is equal to B plus C. There are 64 ways to choose the balls. What is the probability that a student wins the prize? So we've got bin A, we've got bin B, and we have bin C, like that. And now let's place those balls in each of these. So we got 1, 2, 3, 4 in each, like that. So what is the scenario here? We've got someone is selecting a ball from bin A, okay? Then you select one from bin B and then one from bin C. And we want the value of the ball from bin A to equal the values B plus C. So for example, if we chose a ball from bin A and it was 2, then the ball from bin B must be 1 and the ball from bin C must be 1. That's the only way this would work, correct? So they want you to figure out how many ways of that is possible. And they even help you out a little bit. They tell you that the total is 64. We could have figured that out ourselves because from the first bin you have 4 possibilities from the second and 4 possibilities from the third. So 4 times 4 times 4 is 64. But they tell you that. They help you out a little bit. Okay, so let's make a table of these types of possibilities and see what we get. So we got A, B, and C. And A equals B plus C. This is our criteria. All right, shouldn't be that hard to figure this out. So let's start with A. A equal to 1. If A equals 1, what should B and C be to make A plus B A equal to B plus C? If A is 1, there's no way this can work, right? Because we don't have a 0. If this is 1, this would have to be 0 for A to equal B plus C. So A equals 1, unfortunately, doesn't give us any solutions. So that's a dud. How about A equal to 2? Well, if A equals 2, B has to be 1 and C has to be 1. That's the only way this is going to work. A equals to B plus C. So we've got one possibility. If A is 3, then we can have 1 for B, 2 for C, or we can have 2 for B and 1 for C to make A equal to B plus C. So we've got 2 more. Let's see how many more we can get. If A is equal to 4, B can be 1, C is 3, B can be 2, C is 2, and B can be 3, and C is 1. And that's it, right? Because the largest number is 4. So we pretty much exhausted our possibilities. So that's it. We've got six ways to make this work. 6 ways to make it work, and the total number of ways was 64. So that's the probability. If you want to reduce this to lowest terms, you can. 3 divided by 32, I think, is lowest terms probability that they are asking for in this question. Three positive integers, a plus ar, and ar squared form an increasing sequence. If the product of the three integers in this sequence is 216, determine all sequences satisfying the given conditions. So we have a, ar, and ar squared. So increasing, so that means this is greater than that, and that's greater than that. That's what they mean by increasing. And these are all integers. This is an integer, this is an integer, and that's an integer. And they also tell you that the product, if you multiply these all together like this, it equals 216. So we got a times ar squared, so that becomes a to the power of 3, r to the power of 3, and 216. If you take the cube root of both sides, like that, that would give you ar. Basically, you're taking the cube root of a cube. And then 216, the cube root of that is 6. So there we go. There's our fundamental property. And now we just have to make a table and find out possible values of a, ar, and ar squared. So we have ar, and ar squared, like that. And we have to make a table basically entirely looking at that equation. All right, so and remember, these are integers, so that helps us out, definitely. Otherwise, we'd have infinite number of possibilities. So let's start with the basic integer, the smallest one, the smallest positive integer, which is 1. If a is 1, what is r? Well, r has to be 6. And therefore, ar is 6, and ar squared is 36. How about if a is 2? Well, then r is then 3, ar is 6, and ar squared is 18. And similarly, if you keep going through values of a, you will get the following results for a equals 3, a equals 4, and so on. A equals 5, and finally, the largest integer value for a is 6, right? Because if you make a greater than 6, you start getting values for r that are not an integer. We've actually already received values of r that are not integers. But we don't really care so much about r. We really care about ar squared, and ar, basically. We want to see which combinations all three of those are integers. Well, this one gives us all three integers. And this one does as well. When a is 3, we get integers. And I think 4, I think that's it. Because for a equals 5, ar squared is not an integer. And when a equals 6, notice they're all 6. So they don't satisfy the fact that this has to be increasing. Do you notice that is a very important criteria? So a equals 6 gives you 6, 6, 6, which are obviously not an increasing sequence. So the only possible sequences we have for a, ar, and ar squared are 1, 6, 36, 2, 6, 18, 3, 6, 12, and 4, 6, 9, like that. In the diagram, ABC is a right-angled triangle at B. MT is the perpendicular bisector of BC, and M is on BC, and T is on AC. AT is equal to AB. What is the size of angle ACB? There's a lot of ways of approaching this question. For example, there's the immediate way, which I'll kind of show you by blowing up this diagram, is that if you have let's say we don't know any numbers, right? But let's just say AB is 1. They tell you that AT is equal to AB. AT is equal to AB. So that means this is 1, AT. And then they also tell you that M cuts BC in half, right? MT is the perpendicular bisector of BC. So that means this is equal to that. Now, if M is extended up to T, if it cut BC in half, it cuts AC in half. So that means AT is equal to TC, like that. So we can draw these lines like that. So if AT is 1, TC is 1. And then by Pythagoras, you can figure out that BC is equal to root 3. So now you've got a triangle, basically, that has 2, 1, and root 3 as its sides, and this is a right angle. And you know, I hope, by grade 12, that this is a 30, 60, 90 triangle, 30, 60, 90, like that. And therefore, that angle is 30 degrees. That's very quick, immediate way of figuring this out. Another way, which I think is worth doing, is through angles and comparisons. So let's start off by calling angle ACB the angle of interest. We'll call it theta. All right? And then we know for a fact, they tell us in the question, that TM, this line segment right there, it cuts BC in half, correct? So therefore, if you joined a line from B to T, such as that, then that would make this an isosceles triangle, right? That's basically the fundamental property of when you draw a line like TM that cuts the base in half, it makes it an isosceles triangle. So that basically means that this is equal to that. And therefore, this angle is equal to that, right? We all know that. And since the sum of the angles of a triangle are always 180, if this is a right angle, which it is, it's a perpendicular bisector, then this angle has to be 90 minus theta, like that. And therefore, this angle is 90 minus theta also, for the exact same reason. So that takes care of that triangle. Now what I'm going to do is concentrate on this triangle, ABT, that one right there. And in a very similar way, I'm going to label some angles. So, for example, they tell us that AT is equal to AB. AT is equal to AB, like that. So this is an isosceles triangle. So therefore, this angle, if I call it X, has to be same as that angle, X. And therefore, this angle is 180 minus 2X. Correct? So far, everything's fine, right? No confusion, no tricks, no magic. Now we know that the sum of the angles of a triangle are 180. So 180 equals what? Well, there's several triangles in here, so which triangle am I really referring to? Well, I'm referring to the big one, the entire one, ABC, like that. And therefore, 180 minus 2x, this one right here, plus this angle, which we already know is 90. It tells you that it's a right angle, plus this angle, theta. And this looks like we've got the 180s cancel, so 2x equals 90 plus theta. And 90 here is x plus theta, so it's probably helpful to put that in instead of having the value of 90. And then this becomes x is equal to 2 theta. So we've got a very important relationship in our diagram. And now there's one final step. That's it. Let's clean this up a little bit. Our final step is to draw a line from T all the way to AB, like that, so that it is parallel to BC. And that makes this a right triangle. And I hope you notice that this triangle that I just created, AT, right there, is very similar to this one right here. So therefore, if this angle is theta, right here, then that means that this angle in here will be theta also. All right? And therefore, we can find one final relationship, and that is with this new triangle right there. Right there. And that would basically create a situation like 180 minus 2x plus the right angle 90 plus theta is equal to 180. And that's it. That's the equation that's going to help us figure out the value of theta, the numerical value. X is equal to 2 theta, so we can put that in there. Minus 2 times 2 theta. The 180s cancel. Get 90 plus theta, like that. So this becomes minus 4 theta plus 90 is 0. So we got minus 3 theta plus 90 is 0. And therefore 90 is equal to 3 theta. And therefore theta is equal to 30. So as you can see, that's another way of figuring out that the angle was 30. The graph y equals f at x, where f at x is equal to 2x, is given on the grid below. On the grid in the answer booklet, draw and label the graphs of the inverse function y is equal to f negative 1x and the reciprocal function y equals 1 over f at x. So before we can draw the graph, we of course need to figure out what are the equations. Well, y is equal to 1 over f at x is pretty straightforward. They tell you that y is equal to 2x, right? F at x is equal to 2x. So if y is equal to 2x, f at x is equal to 2x, whichever way you want to write it, then y over 1 over f at x is 1 over 2x, like that. Okay, so that's our first equation. How about the reciprocal? Y is equal to f at negative 1x. What that means is you're basically reversing the x and y. So our original was y equals 2x. This was basically our f at x value. Now you reverse the x and y. So instead of y equals 2x, it becomes x equals 2y. Solve for y, and you get y is equal to x over 2. So this is your f at negative 1 equation. So now we just have to plot these. So we'll just make a table, very basic table. And if you have already experience drawing such graphs, you probably won't need too many points. You'll just be able to make a few points and then just make a rough sketch. So for the first one, y equals x over 2. I'll just use this one here. It's got minus 2, minus 1, minus 1, minus 1 half. 0 gives you 0. I'm using this one. 1 will give you a half, and 2 would give you a half, like that. And then for y is equal to 1 over 2x, minus 2 would give you 1 over 4 negative, minus 1 is minus a half, minus a half is minus 1, 0 would be undefined, and 1 is a half, 2 is a quarter, like that, and so on. So you get the point. I mean, like I said, a lot of this is experience in drawing graphs, and it's pretty straightforward. They're not asking for anything magical here. It's just basics. So the first one, I'll label in, let's say, red, this guy here. We've got negative 2, and we've got all the way up to positive 2. So negative 2 is basically negative 1, like that. Negative 1 is a half, negative a half, 0 is 0, 1 is a half, and 2 is 1. So we've got a line basically through those points. So something like that. And then our next one is not a straight line. This one right here, this is more of a graph that has sort of limits. And we'll just start plotting away. Negative 2 is a quarter, so approximately here. Negative 1 is a half, so that actually matches that one. Negative a half is negative 1, so approximately there. and then it goes over to 0, so it looks like it's going to be something like this, like that. If you're doing this for the first time, it might be a little challenging, but if you've had experience, then you will know that. And then it's almost identical on the other side in the first quadrant. It'll be 1 1/2, so that looks like it's on the same line, and then 2 1/4, and 1/2 would give you 1, like that. So in a very similar way, it's something like this. And that's all really they want in this question, is for you to draw and label the graphs of these two functions. That's it. Now we get to part 2. State the coordinates of the points where f at -1 is equal to 1 over f at x. Okay? From the previous question, we had figured out that 1 over f at x has a value of 1 over 2x, right? Because f at x was equal to 2x. They give you that in the original equation. And then f at -1x, well, that was the inverse. So if you remember, we did that as follows. If y is equal to 2x, to get the inverse, we have to reverse x and y. So x is equal to 2y. And then you solve for y, and that makes y is equal to x over 2. So f at -1x is x over 2. So they want to set f at -1x is equal to 1 over f at x, like that. So we got x over 2 is equal to 1 over 2x. And we have to solve for this. So cross multiply, you get 2x squared is equal to 2. X squared therefore equals 1. And take the square root, and you get 1 plus or minus 1. Now they want the points, so don't forget the points. Don't just get x and move on. To get the points, just sub it back into one of these. Either one is fine. If x is 1, y will be, if I use this one for example, 1/2 if x is 1. And if x is -1, y will be -1/2. So our points are going to be 1, 1/2, and -1, -1/2, like that. So there you go. That takes care of number 2. And now determine the numerical value of f at -1, 1 over f at 1/2. Okay? So y equaled f at x, and f at x was equal to 2x, correct? So I'm just going to do this one first. F at 1/2. So I guess plug in 1/2 for x, like that, and that becomes 1. All right? So what this leaves me with is f at -1, 1 over 1. Correct? So we got f at -1 of 1. Now what is f at -1? Well, if you remember, f at x is equal to 2x. That was given. That means y is equal to 2x. To get the f at -1, which is the inverse, if you remember they use that word inverse function, we have to reverse x and y, and by this point you are a pro. So x is equal to 2y, and therefore y is equal to x over 2. So f at -1x is basically x over 2, like that. So this is, if you have a value of x as 1, this would basically become 1 over 2 using this formula. And that's it. That's the final answer.